Welcome. Today we are going to learn about Newton's method. This method can be used to find the roots of any equation. So here the graph shows a function y is equals to fx. Now, what basically is this method is uh, we have some approximations and we approximate till we get to our roots. So our first number can be any number, which can be a random guess, and then if we move on to our second, third, fourth number, which we get through our formula, these numbers, which second, third, and fourth, and so on, these numbers are much closer to our root. So what basically we do here is first we just have some number which we can get by random guessing. So guess a number, and that number has some value of y on this curve on y equal fx. So we get a point. On that point we have a tangent, and we tend to find the the point on this tangent line where y equals 0. That means where this tangent meets the x-axis. So this is one point. After getting that point, we get y corresponding to that x on the curve. Y is equals to fx, and we do the same step again, find tangent at that point and get the value of x where y is equals to 0 on the tangent, and again get the value of y on y is equals to fx, and so on. And you can see that it converges towards the root. So let's see its mathematics. First we have a point slope equation of tangent, that is y is equals to fxn plus f prime xn and change in x. Now we tend to find the point where this y is equals to 0, that means this x1. So by setting y is equals to 0, we get the value of x. Now first xn will be any guessed number. It will give second x, and that second x will be put in this equation again here in this place, and that will give third x, and so on. If we zoom into this area, we will see that the tangents or these points are getting closer and closer to this root, and hence our numbers will also be getting closer and closer to our root. So basically we do two things here, is first guessing a number, and second use that number to get the second number, and the second number to get third number by using this formula. So let's see an example. The question is, find the positive root of the equation x squared minus 2 equals 0. We can see its root is root 2, that is 1.414, and so on. And if we put in the above equation the values, that is for general xn plus 1, we have xn minus fx, which is x squared minus 2 upon f prime x, which is 2xn, means the derivative is 2xn. And by solving it we get xn by 2 plus 1 upon xn. So this is a general equation. Now let's have some values. So for x naught equal 1, we will have 3 by 2, that is 1.5, and 1.5 has an error of 0.41421. That is it has just one correct digit, that is 1 in 1.414. Now that 3.2 what we got here is our x1 to get x2. I mean, now this 1 is used to get x1. Now this x1 is used to get x2 and then x3, and you can see that some numbers are not changing. You will get some numbers which are not changing, and hence you are coming closer to your sought root. So now one basic thing which I have to tell you is that sometimes you cannot get your root which you think you will be getting. So for example, here, if you see the curve, you have a starting point at here. The value of y is on the curve, and the tangent meets x at x1. So you get x1 here, and then the tangent at this point, and you get x2 here. And so you will see that this whole setup is moving towards this root. So if you're thinking that you'll get this root, that's not true. You will get this root. So you're not always sure that which root you will get, but yes, graphing can help you. Graphing can always help you to get your root. So thank you.